Let's talk a little bit about tree diagrams. Tree diagrams are another way to draw pictures, and they can be very effective in helping you find probabilities. The easiest way to show these and talk about tree diagrams is to actually start to make them. Most people have dealt with tree diagrams, but they really haven't developed them in a probability sense. So let's take a look at this example. It says, suppose that 23% of adults smoke cigarettes. It's known that 57% of smokers and 13% of non-smokers develop a certain lung condition by the age of 60. And then explain how these two events, lung condition and smoking, are not independent. And then what is the probability that a randomly selected 60-year-old has this lung condition? Well, I'm going to use a tree diagram to look at all the different things that could happen. So let me scroll down here and look at these two events that I'm concerned with. First of all, I'm concerned with whether or not I am a smoker or not. So you are either going to be a smoker or you are not a smoker. So let me go ahead and write this in. So you are a smoker or you are a non-smoker. There we go. And in the problem, it tells us up here that 23% of adults smoke cigarettes. So I come back down here and I'm going to put a little number on this line, 0.23. 23% of adults are smokers. Well, that means that 1 minus 20.23 or 23% is 0.77, or 77% of adults are non-smokers. So that's one branch of my tree. Now I need to look at this condition, this lung condition. Well, whether you're a smoker or not, you are either going to get the lung condition or you are not going to get the lung condition. So you either get the condition or you do not get the condition. And the same thing is true for if you are a non-smoker. So let me just copy this and bring this down here. Copy this one. Bring this one down here. Let me put all this together. Let me move it over a little bit. I need a little bit more room to do some work. So let's go ahead and put this in here. Now it tells us up here that it is known that 57% of smokers will get the condition. So as I come down here now, 57% or 0.57% of smokers will get the condition, which means that 43% of smokers will not get the condition. And in the original problem, or the original setup, it tells me that 13% of non-smokers will develop this condition. So I come back down here and write that in. 13% or 0.13 of non-smokers will get it, which means that 87% of non-smokers will not get this condition. So I have 4 different branches. You're either a smoker that gets the condition or a smoker that does not get the lung condition. Or you're a non-smoker that gets the lung condition or a non-smoker that does not get the lung condition. So how do I find the probability of each of these? Well, if you listen to what I said, one of the key words for each of these branches is the word and. So if I say it again, you are a smoker and you get the condition. And in probability, when we see the word and, we should multiply. So this is going to be 0.23 times 0.57. And that happens to be equal to 0.1311. So the probability that you are a smoker and you get the condition is found by multiplying these two probabilities on that branch. And I could do the same thing for the other ones. The probability that I am a smoker and I do not get the condition would be 0.23 times 0.43, and that ends up being 0.0989. And then the probability that I am a non-smoker and I get the condition is 0.77 times 0.13, which is equal to 0.1001. And finally, the last branch, I am a non-smoker and I do not get the condition, is 0.77 times 0.87, and the product there is 0.6699. Now I did the math ahead of time. I can't do this in my head. Everybody expects math teachers to do calculations in their head like they're a computer, but I did the calculations ahead of time. That's why I'm going a little bit faster. But one of the nice things about these tree diagrams is that when you make all of the branches and you find each of your individual probabilities for each branch, if you take all of these probabilities right here for each branch and you add them together, you should get 1. So if I add each one of these, 0.1311, 0.0989, 0.1001, and 0.6699, it should be equal to 1. And in this case, I've done the math, and it is equal to 1. That tells me that I probably have done my math correctly. And then I can move on and go ahead and answer these questions. So now let's look at part B first. What is the probability that a randomly selected 60-year-old has the lung condition? Well, there's two situations there. He could be, this 60-year-old could be a smoker that gets the lung condition, and that would be this probability. Or the person could be a non-smoker who gets the lung condition, and that would be this probability. So if I'm trying to find the probability that someone is a 60-year-old, let's write this down. This is actually part B. I'm doing that part first. What is the probability that a 60-year-old has the condition? That's going to be equal to this probability, 0.1311, plus the probability of being a non-smoker and having the condition, 0.1001. And when you add those two together, you get 0.2312. So here is my answer to part B. The probability that a randomly selected 60-year-old has the condition is 0.1311 plus 0.1001, which gives me 0.2312. Now let's go to part A, which is a little bit more in depth, and actually part B will help us with part A. Explain how these statistics indicate that lung condition and smoking are not independent. So I need to check to see if lung condition and smoking are independent or not independent. So I have to go to my independence rules. Let me write this independent rule down. If the probability of, let's write it this way, if the probability of getting the condition given that I am a smoker is equal to the probability of having the condition, then the two events are independent. Independent. There we go. So I need to see if this probability of having the condition, given that I am a smoker, I need to see if this is equal to just the probability of having the condition. Well, I've already figured out what the probability of having the condition is. The probability of having the condition is 0.2312. So I can go ahead and write this down. The probability of having the condition, I'll write it underneath, is 0.2312. Now I need to check and see what is the probability that I have the condition given that I am a smoker. And if you don't remember this rule for independence, maybe look back at a couple of my other videos. I talk about that just a little bit. All right, so what is the probability that I have the condition given that I am a smoker? Now, this is where some people get confused and they make mistakes. They look at that and they say, oh, well, the probability that you have the condition given that you're a smoker, that's right here, 0.1311. Well, that is wrong. Okay, that is not correct. The probability of having the condition given that you are a smoker is going to be this. Okay? The probability that you have the condition given that you are a smoker is going to be equal to, let me rewrite it, the formula for conditional probability says that that's going to be equal to the probability that you have the condition and you are a smoker divided by the probability that you are a smoker. And that's what I'm trying to find. Are these equal to each other? Well, the probability that you've got to use your formula for this, okay? The probability that I have the condition and I am a smoker is up here 0.1311. So the numerator is going to be 0.1311 divided by the probability that I am a smoker, just the probability that the adult is a smoker. Well, that's 0.23. So I come back down here and put 0.23, and I need to check, is 0.1311 over 0.23, is that equal to 0.2312? Well, when I do the math, 0.1311 is equal to, or divided by 0.23, is equal to 0.57. And so that's 0.2312. So no, these are not equal to each other. And look at that 0.57, oh yeah, they told me. That 0.57 is the probability of having the condition given that I'm a smoker. So I kind of did a little bit more work than I had to, but I thought it was important to show you that you need to use this formula for for conditional probabilities to find the probability itself. So I know this was kind of long, and you may want to go back and watch this a second time just to really get it in your mind. But hopefully this helped you to set up a tree diagram and look at the different ways to find the probabilities for each one of the branches, and then a couple of different ways to use that tree diagram.